Now we will look at reducing fractions. We're going to approach reducing fractions from two different directions, and we're going to use two different methods. We're going to look at the greatest common factor method, and we're going to look at the prime factor method. Let's start off with the greatest common factor method. So what we're going to do here is we're going to identify the greatest common factor of each of the numbers, and we're going to divide the numerator and the denominator by the greatest common factor, and that should give us our fraction in reduced form. So now let's take a look at the greatest common factor of 15 and 75. So we're going to put a 15 here. 15, the greatest common factor of 15. So we're going to express this in terms of the prime factors here. So this is going to give us 3 times 5. This is going to give us 3 times 5 squared. So the greatest common factor is 3 times 5, which is 15. So what this tells us is we're going to divide 15 by 15 and 75 by 15. So this is going to give us 15 divided by 15 should give us 1. 75 divided by 15 should give us 5. Okay, so now to the next example. We're going to take 125 and write it as a product of its prime factors. So that's going to give us 5 to the third power, and then 325 is 5 squared times 13. If you need help trying to figure out this greatest common factor, there is a video specially dedicated to this topic. So the greatest common factor is 5 squared, which is 25. So what this is telling us here is we're going to divide 125 by 25, and then we're going to divide 325 by 25. So this is going to give us 5 over 13. Now let's take a look at this set of numbers here. So the first step is we're going to look for the greatest common factor of 216 and 450. So 216 is going to give us 2 to the third power times 3 to the third power. 450 is going to give us 2 times 3 squared times 5 squared. So this is going to give us greatest common factor is going to give us, we're going to use 2 times 3 squared. This is going to give us 18. So we're going to divide this by 18. We're going to divide this by 18. So this is going to give us 12 over 25. So now we have the reduced form. Now the second method we're going to apply is the prime factor method. In this case, I'll show you the prime factors and how to apply the prime factors to this approach. So we're going to rewrite each of these numbers as a product of its prime factors first. So if we look at this, for example, if we look at 15, this is the same as 3 times 5. If you need help with this, you can look at the video on factor trees. It will show you how to get to this. This divided by 3 times 5 times 5. So what you see here is we can cross this out. 3 crosses out, 5 crosses out. So we're left with 1 over 5. 125 is 5 times 5 times 5. 325 is 5 times 5 times 13. So 5 crosses out here, 5 crosses out here. We're left with 5 over 13. Now for this topic, this last question here, we're going to apply the same method. 216 is 2 times 2 times 2 times 3 times 3 times 3. And then we divide by 2 times 3 times 3 times 5 times 5. So this crosses this out. 3 crosses this out here. 3 here crosses out this 3. So we're left with 2 times 2 times 3 over 5 times 5. This is going to give us 12 over 25.